Hi everyone, we the students of Tech Multitech College to present our project in image processing domain named Unique Finger Impression Revelation from single picture utilizing low-level components and examination. The main objective of our project is to increase the accuracy in finding whether the captured fingerprint image is live or fake. In today's world, the use of biometric system for authentication has become increasingly common. Since these fingerprint biometric systems are used excessively, intruders start to attack the system by providing fake fingerprints that looks very similar to the live fingerprint of the user. So, in order to detect the image accurately, we propose the use of directional binary code algorithm along with the novel algorithm surf and fog to obtain accurate gradient features. Similarly, textural features are extracted with the use of Gabor wavelets. As we know, fingerprint detections are software-based approaches because with the usage of hardware, we need additional devices to detect temperature, odor, pulse, etc. And also it would cost much. And these software-based approaches mainly focuses on or depends upon three things. Say, skin perspiration, that is the fluid secreted by sweat glands through pores. Next one is the deformation of skin and the image quality. Software-based approaches are categorized as dynamic software-based approach and static software-based approach. The previous work in deformation of skin uses a thin plate spline that makes the user to apply pressure in all the four directions to measure minute distance between the distorted and undistorted fingerprint. Another method intended the user to move finger while pressing to purposely exaggerate the distortion, and it was observed that live image has more distortion than the fake images. The various static features are histogram, power spectrum, directional contrast, rich signal, and rich thickness of finger images. In the perspiration-based approach, the finger impressions are captured at different intervals and the rich signal extracted are then compared, which then uses a backpropagation neural network classifier to differentiate the live and fake images. The fake images contain air bubbles and are created by using gelatin clay, latex, wood glue, etc. The major disadvantage is that the user needs guidance while rotating finger. Also, the computation time is larger since there is more number of feature images. Here are some of the previous work that I have mentioned the literature survey that doesn't use the directional binary code. So the accuracy of the finding of whether the given image is whether live or fake is not accurately found. It is quite difficult to visually differentiate between live and fake images. Therefore, we use three process stages, namely image processing, feature extraction, and image classification. Enhancement of image quality and noise reduction are the two main factors in pre-processing stages. The enhancement is done by first cropping the fingerprint region and perform a histogram equalization. Then median filtering is applied to the cropped image to reduce the noise. The surf and fog algorithms are initially used to extract the gradient features and Gabor wavelet to extract the textural features. Along with this, directional binary code algorithm is used to accurately extract the feature. Then all these feature sets are given to principal component analysis that reduces the number of data sets. With the usage of all these algorithms, the quality of the image is improved and not much data sets are required. Also, it provides accurate result in detecting the live and fake images. Here is a system architecture of our project where we have three process stages. The first one is the image pre-processing stage, and next one is the feature extraction stage, and finally the image classification stage. In image pre-processing stage, we first obtain the original image and then we crop the image and resize it and convert it into grayscale images. Here, the noise reduction is done and the histogram equalization is produced. In the second stage, that is the feature extraction stage, we use the surf algorithm and fog algorithm to extract the gradient features of the image, and we just give those features to the principal component analysis. The principal component analysis here reduces the number of data sets that are produced by using the algorithm surf and hog. Simultaneously, we use the Gabor wavelet. Gabor wavelet is used to extract the textural features of the given image, and the output of the Gabor wavelet is given to the principal component analysis that gives you the feature vectors. And in the third stage, that is the image classification stage, we use the SVM, that is the supporting vector machine, and also the random forest. These are used for classifying the images, and with the use of score integration level, we just classify whether the image is live or fake. The hardware and software requirements for our project is that the hard disk should be minimum of 40 GB and the RAM is 512 MB, and the processor used should be Pentium 3 and above. And for our project, we use the MATLAB software of version 8.3.0, and Windows operating system can be Windows XP and above. Here are some of the modules that I have mentioned of my project. The first one is the pre-processing stage that uses the surf algorithm and extraction of features by using the fog and DBC, and finally we use the extraction of textural features by using the Gabor wavelets. In the module 1, we just define the pre-processing stage where there are two factors that are mainly focused, that is the image quality enhancement and the noise reduction. And next comes the surf algorithm. Surf algorithm has two components, namely descriptor and detector. The detector locates the key points in the image, and the descriptor describes the features of those key points to construct the feature vectors of that key points. Here I have described the surf algorithm where we should form a scale space response by using some filters such as DOH, and we have to find the local maxima along all the neighboring pixels. And after finding all those local maxima, we have to interpolate those locations, and finally we have to return those values by using the DOH magnitude and the Laplace sign. Uh, in the model 2, the feature extraction, we use the fog algorithm and DBC algorithm. Fog algorithm here is used for extracting the appearance and local shape of the image. It captures the intensity gradients and the edge directions that describes the features of these images. And next comes the directional binary code algorithm. This algorithm is applied on the image for encoding purpose. Uh, the main procedure here is that if we have uh, image size of 50 into 50, that should be partitioned into 100 cells of 5 into 5 matrix. With this 5 into 5 matrix, we just consider only the 3 into 3 neighborhood center where each cell contributes one coefficient. The algorithm steps are described here. That is, we have to first extract the 5 into 5 matrix, and then along each pixel we have to derive the directional derivatives along the 0 degree, 45 degree, 90 degree and 135 degree. These derivatives are converted into binary format, and these are read in the anti-clockwise manner. That forms a 9-bit binary code. And these 9-bit binary code are then converted into decimal equivalent. And these decimal values of all directional derivatives of each cell are averaged into a single value to obtain the coefficient per cell and 100 coefficients for the whole image. Then the Euclidean distance between these feature vectors of images in database and feature vectors of test image is computed. If we find the minimum Euclidean distance, then it is considered as the matched image, that is the live image. If that doesn't match, then it is called the fake image. Next, we use the Gabor wavelet. Gabor wavelet is used for obtaining the textural features of the image. Here, all the similar Gabor functions are collected and two processes are done here. One is the dilation and another one is the shift operation. The wavelet has the energy localized at x equal to 0 and it is normalized to form a discrete set of frame. Here local ridge characteristics are extracted using the Gabor filters then whose frequency corresponds to the inter-ridge spacing in the fingerprints. After all this process, we use the principal component analysis where we select a tree which is fit for the surf algorithm, fog algorithm and DBC algorithm, and finally Gabor features. And with the usage of this, we can distinguish between the live and fake fingerprint images. These are the screenshots of the demonstration of the project. The first one is the main module execution. We create a main function uh, that consists of all the uh, calling of functions like Gabor wavelets, directional binary code, database, and all the functions we used here. And next one is the main module execution. Here we run the project using the MATLAB software, and this is the just an illustration of the database. We have to select the database folder where we can find number of images that is already stored in the software, and we have to select any one of the fingerprint image, and it detects whether the given input image is live image or fake. And I would like to conclude my project uh, that uses a novel method for fingerprint liveness detection by combining all the low-level features, gradient features by using the surf and fog algorithm and the textural features from the Gabor wavelet. And we use a directional binary code algorithm for the feature extraction and to increase the accuracy of the image that well discriminates whether the given input image is real and fake. In the previous datasets, the accuracy dropped severely and did not perform well with the sensors. So, to increase the accuracy and to keep the test datasets balanced, we consider the equal number of live finger impressions as fake fingerprint impressions. Thank you.